Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you.
I have created a cheat sheet document which is having some, so far we have a lot of links that we need to follow, right? Some documentation, projects, some external videos, a lot of things, right? I put together all the at least important links that you need to go through to complete your preparation to start attending the interviews or in one single sheet. Like if you go over with these links, right, it will be helpful for gaining more confidence, more technical knowledge. So I just put together some of the important stuff. So I will be sharing this link for you guys for a reference to go over with all of these links and revise your concepts again. Yeah, that's one thing that I would like to do from my side. I will ask the third thing is I'll ask the admin team to share you the the information about the resume preparation stuff. Like usually the process is like you guys has to send a mail to the mail ID that the admin team share. So we can send a mail asking for a resume, and you'll be getting the resume right on that based on your query and your questionnaire, right? So I'll ask admin team to share the information how you can approach them to get the resume help. Okay. And I have already informed the admin team to give you the access for the two Udemy projects that I have talked about the other day. So probably you will be getting the details about those two projects, right, in day or two, right, for you to go over with these, you know, uh, projects that I'm granting the access at Udemy. So whatever the projects that are there in the Udemy are we already discussed them. Okay, those are not completely new. We already talked about them in our lectures only, but I just put together the projects in a nice format, in a in a concrete format, right, that helps you to go or revise the concepts again. Nothing much, not new things actually, right? So you'll get the details in your group how you can enroll for that projects for free of cost, right? In a day or two, you'll get the some instructions, right? Now, so I think most of the assignments are solutions are provided, and maybe few assignments the solutions are not granted. But though the I meant to say at least 50% of the concepts that are covered in the assignments are actually covered in our course itself, right? But I just given that as part of the projects kind of or the mini assignment kind of, right? But yeah, I'll try to record as when I get some time. I'll record the solutions for the remaining assignments as well, and I'll be uploading into my YouTube portal. I'll share the links as well, right? The way like today I have shared one of the YouTube link, right, where I have recorded some of the small traffic flow management. Well, so yeah, uh, yes, I think those are the couple of things that I wanted to talk about, right? Because we are trying to end up our lectures. I just wanted to talk about the the closing notes, right, and how it will be. I think looks good. Now let me get into our story for today. Well, so I think we have completed all the technicalities at least, right? The major or like at least uh, to the level that you would like to the level that you need to learn, right, to crack the interviews, right? We are already done with that skill set. Now it's all about understanding the use cases and the improving the thought process right? What are all different ways to integrate these tool set? What are all different ways to build and deploy application, and the different ways how are the different tools that we can use for the same problem. So this is all about the more of a research, more of investigation, more of thought process that we need to apply through, right? But the technical concepts we are already done. The same technical we can use in a different ways, right? Depends on the person, that depends on the use case, that depends on the project, depends on the company, standards, whatnot. We already familiar by now, right? The DevOps is all about a process oriented, how an individual can apply these technicalities it into their own process to solve the problems, right? Correct. Well, so I just wanted to talk about one thing, right? Let's say if I take one shopping portal web application which I wanted to make it deployed and run as an application where my end users are accessing my application, right, for purchasing my products. Let's say the other day I have shown you how to build and deploy this React application, right, which will be giving you the front end UI, and that will be sending the traffic to the backend RESTful API, correct? The RESTful API will be actually connecting to the database, right? That is how the general three-tier architecture works, right? So I'm just putting the things together, guys, today, right? We already completed all of the things, right, already. So here I'm just calling out that whenever the end user is accessing my website in the browser, somehow the request will come to the cluster IP service of your React application, and that will be routing the traffic to the backend RESTful API, correct? I'm not talking about all the different networking layers that are involved here, correct? Of course, in every slide we can't put together all the tools, all the integration, correct, guys? Let's say in this presentation I'm saying that the request is coming to the React application. How it is coming to React application, right? The request is going to AWS load balancer, then the ingress controller will be there, the ingress rules will be there, cluster IP service will be there, then it will come to the pod. I don't need to talk about that whole network layer in every lecture or in every presentation. So it's easy to understandable, right, how the things happening behind the screen. Agree with me, guys, correct? So what are the major point that we need to focus on that particular discussion? So my slide is prepared in that particular fashion, right? Just for avoiding the other complexities, but all these things will definitely be there, right? Because by now we already know that how the access will be, or how a application will be accessible from outside world, right, when it is deployed it into the Kubernetes cluster. Are we good on the same page? Thank you. So the thing is, right, so in this particular scenario, let's say what kind of the features that my website is giving to my end users is the next thing that I would like to talk about. For example, or call out some of the features, guys, that you may be seeing in a shopping portal, a typical shopping portal website. In general, if you take the shopping portal website, right, you may be having the product listing in the home page. You maybe have some sign up functionality, sign in functionality, select the product and add it into the cart, do the payment, order will be created. You go and look at the order in your profile, right? And then you verify when the product will be get delivered to your doorstep. Pretty much this is the a flow how a typical shopping portal website will be working, right? So those are very general or the mandatory features. But beyond that, right? If you look into any one of the portal like Amazon here as an example, which is one of the real time, right? This Amazon.com is having multiple of features that are offered to the end users, right? You see here it has something called Medicare, groceries, right? And maybe the best seller items. It has a prime concept, right? Maybe the custom service related feature, maybe the music. So basically think of like each tab that you see here is a separate a feature that the Amazon is offering to the end users, right? And it includes the cart management, right? And the profile management where you can register your account and sign up, a lot of things, right? Now help me guys in the chat window, whatever the UI that you are seeing here. Now can you imagine that this UI is coming from the React application? It could be any other UI tool, but just for understanding our purpose, right? So let's say this whole UI is coming from the React.js application, which is the front-end application. So let's say whenever you hit amazon.com, the request is going to the front-end application, which will be giving you this nice graphical UI. But whenever you are doing any functionality execution like sign up, sign in, payment, adding the product into the cart, whenever you're doing all of these, do you think that that functionality is being done by the UI or the front-end application? No, right? The functionality is actually done by the backend application, correct? So the front end is actually sending that request to the backend. The backend will take care of doing that whole business logic. But now the thing is, do you think a simple backend application, a one backend application is enough now to take care of all the different features that the website is offering to the customers? It's not possible, right? So in this case, right, as I said, the payment, sign up, sign in, right, and order, cart management, and you see few other as well in the Amazon, like groceries, medical, music. So all these functionalities cannot be handled by one single application in the backend. So that is where now the developer is moving ahead with the concept called microservices. In the sense, the developer who is writing the code for your backend application is not putting one single application to handle everything. Rather, the developer will be dividing, splitting your whole application functionalities it into a microservices. So the microservice is again a Spring Boot application only, no difference for us. But the microservice is handling the specific functionality of your product, right? So if you look at here, right, now rather having one single backend, the developers are writing the code for multiple. You see here, let's say one is the catalog application. So catalog is the name of the application, which is again a Spring Boot application, right? The developer will write a Spring Boot code for this catalog application. This catalog application purpose is only to show you the product images in the front end UI. Whatever the product images that you see, right, all those will be coming just because of this catalog UI, or sorry, catalog microservice. So the other day we have seen, right, usually it will be getting the images from S3 bucket and all. So somehow the developer know how to write a code, how to get the images from S3, how to give that images back to the front end. The front end know how to show the images in the front end, right, to the users. So basically the catalog is one of the microservice which handles showing the product images. Let's say the one more microservice called user. This service is responsible in doing the sign up and the sign in functionalities. In a front end, if you are registering a new user or you are logging into the account, that will be handled by this particular microservice, right? So whenever you are clicking on sign up, the request will come to the user service, and this will take care of doing the registration and storing the credentials it into the MySQL database. Remember guys, I have shown you already this how exactly, right, how exactly the the microservice, the Spring Boot application will be storing the registered credentials it into the database, right? So the same thing will happen here. So similarly, let's say there is a one more microservice called cart. This microservice is responsible, right, in managing the cart system, in the sense when the user is adding any one of the product into the cart, storing that into the cart, showing the cart profile, how many products are in the cart, all these things will be now handled by the cart service. So like that, the overall website functionalities are divided it into multiple parts, and each feature is handled by a separate service, which we are now calling it as a microservice. Right? Let's say you are doing the payment, that will be handled by the payment service. Right? And once the payment is successful, let's say it has to handle a order, your order will be placed, right? It will be handled by the order service. So that means what? In the real time, when it gets into right, there will be multiple microservices that will be get deployed in order to handle your final product. It's up to the developer and it's up to the business, whoever is they're deciding basically how many microservices that would be needed, right? Let's say, just to call out, let's say the user service is handling the sign up and sign in, but it's up to the developer. They can have one service for handling the sign up. They can have a one more service for handling the sign in, possible, right? It's up to their thought process, the developer's thought process, how they wanted to divide this whole product features it into how many number of microservices, and accordingly they will be start of writing the code base, right? So whenever there are multiple microservices are deployed for a single product, for a single project, right? So always there will be some dependencies, right? So let's say sometimes the payment service may need to interact with the order service. The catalog service may need to interact with the cart service. Correct me, guys. Why? All these microservices are actually working for the same website, the same product, right? The front end, the user, whoever is accessing my website, they will never worry about whether this is handling by one service or multiple. So in order to make a smooth operation to the end users, right? In the backend, all these microservices will be connecting together and will be exchanging some data. All these things will happen. But again, it's developers' risk how they are writing the code, right? And how they are putting the dependencies in the pom.xml file, right? And in a application dot properties file in the src main resources. So it's up to developer how they want to manage the microservices, right? How they wanted to put the dependencies and all, right? Whenever there are multiple microservices are there, right? Now it's a very tough for my front-end application to route the traffic to the backend microservices, right? If it is one is fine, but when you have multiple, let's say the users clicking on a sign up, how would your front end know that the request has to go to user service? Let's say the user is clicking on payment, how would the front end know that the request has to go to payment service? So for that reason, we are using the API gateway. Again, API gateway is also a service. For you, it doesn't matter what is the functionality of the application, right? For you, it is just an application. Take it, build it, deploy it. So the API gateway is again a one of the application which the developers are writing it for you. You take it, you build it, you deploy it. The way how API gateway application works, right? Whatever the request that comes from the front end, now the API gateway will be taking care of routing it into the backend applications. Of course, there is one other service called registry. So basically, all these microservices are getting registered with the registry microservice, so that it's easy to understand that all the microservices are healthy, not healthy. It's kind of the management related things that the developers are deciding, right? So the front end API gateway will be routing it into the backend microservices with the help of the registry to understand the endpoints of each and every microservice. So here, each and every microservice is doing its own job, right? Or the purpose in a way, or maybe a feature, a specific feature is being handled by each microservice. But in general, tell me guys, you as a DevOps engineer, will you be really care about the feature of a microservice, what the microservice is doing, right? How the microservice is functioning, right? So how it is behaving. Do you really need to worry about that in general? If you know that, it's well and good, right? If you know what is the microservice, what kind of the feature that the microservice is delivering, it's well and good. But that's not important, or that's not needed for an DevOps engineer to know. Sometimes the developers may help you or may explain you, hey, my microservice is doing this kind of the functionality in my application. Sometimes they may tell you that take the code, build it, deploy it. We never know what the microservice is doing or how it is working as well. So your role is take the code, build it, deploy it. To build it and to deploy it, how the CI pipeline, a CD pipeline needed, you write a pipeline job, right? Prepare a pipeline code, right? And do all the efforts that have put in right in Jenkins. You do everything and make a pipelines ready. You put all of your efforts to bring up your Kubernetes cluster. You put all of your efforts in AWS to make your infrastructure ready. That means what? To build the application, to deploy the application, whatever is needed, you ensure all of these things are get deployed, prepared, and let's ensure that the application is deployed. That's it. That is your job. How these microservices are connected one each other, and what kind of the functionality, how the traffic is flowing, the dependencies, everything known by the developers, and they will decide how it has to be working on. So I have already shown you the CI/CD pipeline for one application, right? The same CI/CD pipeline that you need to repeat for all these microservices. So today the developer come and tell you that, hey, I have a catalog microservice. Can you build and deploy? Now you create another CI/CD pipeline for the catalog Bitbucket repository and ensure that that project is being building and deployed. So tomorrow again the developer come up and say that, hey, I have a cart microservice. Can you build and deploy this? You prepare a pipeline, you make it build and deployed. Sometimes the developer may give you some instructions, right? Hey, this cart service need Java 8. This catalog service is actually a Python. The payment service, let's say user service, is actually interacting with the MySQL. So you need to give the MySQL endpoints in the application.properties. So that means that there will be small there and there some differences will be there in terms of the build behavior, build dependencies, version compatibilities, the number of stages that the developer is looking for in the pipeline, right? So based on that, we need to do little tweaking in the CI pipelines and ensure that it is building and deploying as per the developer's expectations. Are you following me? So being said that, since we already spent some time in building and deploying one microservice, which is a repetitive task for all of these microservices again, so which I'm not doing now, right? But think of like this is how you will be spending the time in building and deploying, and which is a continuous process, guys. Let's say today I have some 5-6 microservices, right, which are helping me for my website. The website is keep on improving, right? If you think about your any one of the shopping website that you guys are using, like Amazon, the Amazon is keep on adding some new feature, right? New improvements, right? So last month when you access your Amazon portal to purchase a product, and today you log in again, you may be seeing a lot of differences in the website. How that's happening? The developers are keep on introducing new microservices, keep on updating the existing microservices. So you are there to take that changes, take that new services, and ensure that the CA and the CD is happening as expected, and all of them are building and deploying. That's how it is. So in general, what do you think? How many microservices may have for a general, regular, normal project, a medium-sized project. When I say project, your product, right? Let's say in this case, the Amazon is called as a one product, or maybe a project, shopping project, right? So in general, at a medium-sized project, right, there will be at least 100 microservices that will be running in your Kubernetes cluster. As I said, like catalog, cart, payment, user, order, right, registry, API gateway, right? There will be for tracking, there will be for order delivery, there will be one for SMS deliveries, one for email delivery. I'm just calling out few just to understand this, right? So, so in general, right, you go to any one of the shopping website and just look at the different tabs, different features that you have. Every feature that you see will be a definitely one microservice in the backend. So as an average, there will be a 50 to maybe 100 microservices that you need to build and deploy, and that count will be keep on improving. As and when the business is adding a new feature in the website, that will become a new microservice in the backend, which you need to support to build and deploy and create a pipelines and managing that stuff. Let's say there are 100 microservices in general. Let's say there are 100 pipelines. Definitely, right? Any one pipeline will be keep breaking. Any one pipeline will be keep failing in the build process due to the version compatibility differences, the developer code changes, some dependency is missing in the pom.xml just because the developer is not putting the things right, and you need to be there to see why the build is failing and report it back to the developer, work with the developer, do the changes as needed based on the latest code changes. Getting me, guys? That's how it will be. It's not one single pipeline where you are just taking the code and building and deploying, then what the DevOps engineer has to do next. No, right? So that's how there will be a usual, there will be, day to day some practice will be there in managing all of your 100 microservices are working as expected in our Kubernetes cluster. So as I said, right, I don't need to show you again how to build and deploy each and every microservice, because that is again a repetitive task for me, the way how I did it for one application. But I have repeated the steps again and again for every microservice. That is what I recorded, and I am giving the access which is uploaded in the Udemy for you guys, just to see how all of these are actually built and deployed. Are we good on this? Now the thing is, whenever you have multiple microservices like this, right, uh, probably it will be difficult in order to, right, in order to monitor them. What is it mean by the monitoring here, guys? In general, when I say a monitoring, right, probably now I need to look after the CPU and the memory utilization of each and every pod. Let's say, let me take one microservice. Let's say the cart microservice is built and deployed it into my Kubernetes cluster, which is running currently. I want to know this microservice is running healthy. In the sense, the compute utilization, I wanted to know that how much percentage of the CPU and the memory is being used for this microservice. I want to know that. Like that, I wanted to know the utilization pattern of each and every microservice. Remember, guys, in general, when you're deploying any application, you can give the request and the limit, right? But on what basis you decide the request and limit? How do you know that the application would need how much CPU and how much memory, correct? So in general, you give some, but then you need to look after how it is functioning, how it is working, whether the given processor and memory is enough or not, how much is being utilized. You need to look back that details and revise the numbers, right, based on the things, correct? So how are you going to monitor that information for all of these microservices is the next question for me now. Maybe I wanted to look after the compute utilization of each and every pod, compute utilization of each and every worker node, right? Maybe I wanted to look after the metrics. When I say metric in the sense in general, right? How many requests are that are coming into each and every pod, how many requests are failing, how many requests are successful, right? Maybe I want to know all of that information here. That is outside of, like, after you build and deploy, right? Later, this monitoring aspect is just to ensure that your applications are running as healthy with all the best practices are in place, correct? So when you are monitoring the application, if something goes wrong, then we'll be keep on fixing them, correct? So if it is one application, is fine, but if you have some hundreds of microservices like that, it's very difficult to monitor them. Hence, we need to come up with the monitoring solution like a Grafana. So let's say I'm just introducing you the Grafana and the Prometheus stack project here. So here, like, if you have a application running in the Kubernetes cluster, right? So here my requirement is to monitor this application, right? So monitor in the sense what? Again, I wanted to monitor CPU, memory, right? Compute, and some of the metrics like how my application is behaving and how many requests are coming in, right? How many requests are going out, how many are failure. Maybe I wanted to know all of this information, anything related to the metric perspective. To monitor the metrics of your application that is running in the Kubernetes cluster, right? So here I'm deploying or I'm using a tool called Grafana. So Grafana is the monitoring UI software. The Grafana software will help you to show you the metrics of these running applications in the nice dashboard. But the Grafana software is not capable to collect the metrics of your running application. So the Grafana is actually depending on the Prometheus application. All what you need to do is first you need to deploy the Prometheus application. Prometheus is again a name of the application. The Prometheus application is now responsible to do two things. The one is the Prometheus application will collect the metrics of your applications. Second, it will store the metrics into the Prometheus database itself, right? So I would say like Prometheus is the metric collector and the data store. So the Prometheus will collect the metrics from your running applications and will be storing them into the Prometheus database. The Grafana is just taking the data from the Prometheus database and showing that data into the graphical user interface like that. You see, the Grafana will just show the data that is stored in the Prometheus database in a nice graphical format like that. That way now it's easy for you to monitor any application that you wanted to. You can just go to the Grafana and look into this particular graph. The graph will tell you at what time, which pod, how much utilization, all these things. So it's a very easy way to navigate through and look after the metrics of your interested things. That's it. So simply put, in order to monitor your application's performance and the metrics in a nice UI, so you need to deploy the Prometheus and the Grafana. Prometheus is now responsible for collecting the metrics and storing it into the Prometheus DB, and Grafana is just collecting that raw data, right, and showing that it into a nice dashboard format. So here the Prometheus and Grafana are the applications which are doing some kind of the monitoring job for you, which are again running as a pod in the same Kubernetes cluster, right? You install the Grafana software as a pod, you install I mean to say you deploy the Prometheus to run as a pod. So these are the monitoring pods that are running in the cluster, which is right. One is collecting the metrics, one is showing the data it in the graphical UI format, right? So these are not running in the inside a pod, guys. These are the separate pods. The Grafana and Prometheus are running as a separate pod running in the cluster, which will be taking care of this monitoring job for you. So simple, right? So from the roles and responsibility perspective, right? So if you know how to go to Grafana, how to read this dashboards, that is good enough. I mean to say, you need not to be expertise in how to install the Grafana, how to install the Prometheus, how to set this whole monitoring stuff from the scratch, how to set up these dashboards. You need not to expertise in all those aspects, guys. Right? If I ask you, hey, can you check this application, how it is working, right? If you know how to go to Grafana, how to look into the dashboard, how to see these values, that is good enough. Why? In general, setting up this Grafana Prometheus is one-time job, and mostly that will be taken care by the different team, not a DevOps team, right? Even setting up this dashboards, like whatever the graphs that you see, right? Setting up these graphs and all will be done by a different teams. In general, right, the companies are hiring a engineers like observability manager, observability engineers, right? In general, right? This is a different job role altogether, right? So dedicatedly, the persons are hired these days who are actually working on the monitoring setup only. So that team will take care of installing this monitoring stack, setting up the dashboards, configuring the dashboards, all of these things for you. So you are not doing all of these right in real time, but if you know what it is, how it works, how to look into the dashboards, that is good enough. And again, so at 1% cases in some projects, if they are not having the separate team, they may ask you as well to do little changes there and there. But again, that will be uh, in general the add-on things to the DevOps engineers. And no, even in interviews, no one will be really focusing on if you know how to set up this whole monitoring stack, because in general, right, this is the add-on skill set. I mean to say, if you're strong enough on how the Kubernetes works, if you are strong enough on the AWS infrastructure, if you're strong enough on the automation, how the pipeline works and the Terraform works, that is good enough. All these things we can easily, get the things, and easily can be configurable, right, by just following the documentation. Agree with me? So from the scope perspective, it has a lesser priority or the less weight. So just having some idea is good enough, guys. So I just see a question in the chat window, right? The Grafana, or I would say Prometheus, is is the monitoring solution. What is that it is monitoring? It is going to monitor the metrics of your application that is running as a pod. Let's say I have a catalog service is running. How the catalog service is running, how much is being utilized from the compute perspective, right? That kind of the behavior, application behavior will be collected, and that behavior will be putting into the dashboard. Then, so do you think this monitoring the Grafana and the Prometheus stack will give you the CICD status? Definitely no. And again, I don't need a separate tool to talk about my CICD status. The Jenkins itself is giving you the beautiful CI/CD history, right? The other day we have seen that the Jenkins is showing the build number 1, build number 2, build number 3, which build is failing, why it is failing. The Jenkins itself is giving you the CI/CD whole list over there. So the Grafana and the Prometheus stack is completely for a different purpose. It is just the applications, the actual applications behavior will be collected and putting into the a nice dashboard format. We'll see how to run this, guys. Just very simple. So we just need to go and download the required this is the list of links. All what you need to do is just go and download the Prometheus deployment specific manifest files and just deploy them in your cluster. That's it. So if I look into the GitHub page here, right, this is where you can see the Kuberenetes project. In this Kuberenetes project, by the way, this is the open source, okay? The Grafana and the Prometheus are the open source softwares which you need to just get it and deploy and run them for you. There is no licensing is applicable here. So maybe just to look at the question, right? The Grafana and the Prometheus combination that I'm using here is exactly like a CloudWatch, no difference. But do you think the CloudWatch will help us to give you the monitoring aspect of your application that is running in the pod? Not definitely. The CloudWatch will give you some kind of the metrics at a AWS infrastructure level. The CloudWatch will never give you the applications that are running in the pod level, right? That's it. That's the only reason why I'm using now the Grafana Prometheus stack. The Grafana Prometheus stack will give you the kind of a CloudWatch report only, but it's all about your applications running in the pod, not at a infra layer, right? So if you look into this Kuberenetes project, it has some bunch of files, guys, with the documentation as well, how it will be working and all the things. So if I look into here, you can see the manifest section. Under the manifest folder, this is where you can see some bunch of manifest files that you can use of. So all these are the Kubernetes manifest files that you need to deploy to bring up the Prometheus and the Grafana stack. You don't need to develop the manifest files because this is a generic application, right? You just need to download all of these manifest files and apply them. That's it. It take care of creating whatever is needed for you to run the Kubernetes and the Grafana stack. The same manifest files that I found it from this GitHub, I actually collected and I kept it into my own repository too, which I can use now. Even in the real time, the people will be using the same files, guys. They will be downloading it from the same GitHub repository, same files will be get deployed since this is the open source project. So let me clone my repository. All of my Bitbucket repository links are updated for you guys. You also can make use of my repositories and the code. I'm just cloning my Kubernetes repository. So if I go to the Kubernetes folder here, I have the manifest file folder. Here I can see the Grafana folder. So here I can see the in the Grafana folder as usual, right? Like in here you can see some files are here. There are some files under the setup folder as well. Right, the same files I downloaded and I kept it here, no difference. So whatever is there under the setup folder, those are the prerequisites. That means first you need to install the setup folder files, then you need to install the files that are outside of the setup folder. In general, inside the setup folder, whatever is there, those are setting up the namespace, all these things. You see here, it is actually deploying this Prometheus Grafana it into its own namespace called monitoring. So it creates the namespace, all the required stuff, maybe the service accounts, right? That kind of the things will be get created here. So let me go ahead and deploy them now. Under the Kubernetes, under the manifest, under the Grafana folder, right? Under the setup folder, sorry, Prometheus Grafana stack, under the manifest folder, under the setup folder, kubectl apply -f dot. In general, dot refers present working directory. That means all the files having an YAML extension, all of these files will be get deployed at one go. So here, since I have multiple files that I need to deploy, right, I'm just using dot that deploy all of the files for you. I just have downloaded and I'm just trying to run. This is brand new EKS cluster. Let me run AWS EKS update hyphen kubeconfig. Name is EDEKS01 region US East 1. Now let me deploy all these set of files. Done. So it basically created a service account, namespaces, all this stuff. Now let me come back. kubectl apply -f dot. Now I'm deploying all other files, whatever you see outside of the folder. Believe me, even in the real time, we'll be deploying all of these files as is these. Download it from the github.com and just deploy it. It's done. Let me clear the screen. Now let me see this case. kubectl get the service on monitoring namespace. So it has multiple services that is got deployed here. Okay. So at high level, you see, right, it is deployed Prometheus operator, Prometheus operated, Prometheus KTS, Prometheus adapter, node exporter, cube state metrics, a lot of things. Anyway, it's a big project anyway, right? It has created multiple services. Out of all the services, which is the service that I'm interested on at this time, guys? My goal is to access this kind of a dashboard from my browser, right? That is my goal. So to access this browser, I need to get the I need to send my request to whom? I need to send my request to Grafana, right? So Grafana is running as a pod that is accessible through a service. I'll show you the pod now. kubectl get pods on the monitoring namespace. There are multiple pods that are deployed here, guys, and if you closely look at here, there should be one pod that is a Grafana pod, you see. So this is the Grafana pod that is now responsible to give you the UI. Kind of like this is the front-end application, okay? Think of like the Grafana is the front-end application now to give you the UI, and Prometheus is the back-end application which is taking care of the metrics collection and storing it into the database, kind of, right? So to access this Grafana application, right, now I need to look at the service, correct? kubectl get service on monitoring namespace. And you see here, there is a service called Grafana, the service of a type cluster IP. This service is listening on port number 3000. Now help me guys, how do I access this Grafana application from my external browsers? Ingress, right? I should install the Ingress and the Ingress resource, correct? Same concept. So now let me deploy the ingress controller. So I'm just checking where is my ingress controller manifest file. So kubectl apply -f. Here I can see my ingress controller manifest file is there. We are already familiar with this, how to deploy the ingress controller. Once the ingress controller is deployed, now we need to deploy the ingress object, correct? You see here, the kind is ingress, let's say grafana dot, let's say shopper, right? If at all the client is requesting for grafana.shopper.com, the request will go to the Grafana cluster IP service on port number 3000, right? So let me deploy this ingress service. kubectl apply -f ingress for Grafana. Since my Grafana application is deployed it into the monitoring namespace, and even my ingress also deployed it into the monitoring namespace only, right? Let's say kubectl get the ingress on monitoring namespace. So I'm just waiting for this to show my load balancer endpoint. Here we go. Now all what we need to do is configure the DNS accordingly, correct? Let me logging into my AWS to configure the DNS so that I can access my Grafana. Create a new record. Let's say grafana.shopper.com should be accessible pointing to this load balancer. Now let me go to the browser, grafana.shopper.com. I'm just trying to access the Grafana application. It may take time too. While it is trying to connect, right, let me come back here and let me show you something. So can I say that whenever you are trying to access this UI from the browser, the request is going to the Grafana. Now the Grafana is connecting to the Prometheus to collect the data to show that it in a UI, right? So how would the Grafana application will be connecting to the Prometheus application? Prometheus is also running as a pod, right? Prometheus is also running as a pod. How would the Grafana is connecting to the Prometheus? Through a cluster IP service. Any application wanted to connect with any other application, it has to go via the cluster IP service only, right? So now the Grafana is connecting to the Prometheus using the cluster IP service. Even the Prometheus will have its own cluster IP service that I can show you now, right? If I run a kubectl get the service for monitoring namespace, somewhere you can see that Prometheus-K8s, that is the name of the service, and this is the cluster IP service, guys, which is listening on port number 9090, right? So if the Grafana has to connect with the Prometheus, the Grafana has to use this cluster IP service name. When it uses the cluster IP service name, it automatically directing that connection to that specific cluster IP service. And as usual, once the connection come to the cluster IP service, it will be routing to the backend ports based on the label concept and all. So even if you look into the Grafana Prometheus stack deployment, for example, if I go back to this manifest files, definitely there will be a manifest file to deploy the Prometheus service. You see here there is a file called Prometheus service, and if you look into this manifest file, the kind is actually a service. The service name is Prometheus-K8s, which is listening on 9090, right? The type is cluster IP service, and of course it's a default when the type is not mentioned, right? All these things. It has some labels concept as well. The traffic has to go to which pod, all of these. Just trying to show that information. Well, coming back to here, right, now I can see that the Grafana is accessible. The default username will be admin. The default password will be admin the very first time when you set up the Grafana, and then you log in. Once you log into the Grafana, this is how the Grafana UI look like. All what you need to do is go to the data, go to this dashboard section. So here you can go to the manage, and here you can see the dashboard name. All these are the dashboards that are auto populated for you based on your deployment, guys. Now let's say I wanted to know the cluster wide computing resources. Just go to this. Now you see this is the utilization metrics of your cluster. When it says cluster wide, it is at overall, at overall the Kubernetes cluster wide. I think it is having some breakup as well in terms of the namespaces too. In each namespace, how many pods are running, what is the CPU utilization at a namespace level, right? And all the details. The memory utilization is available in terms of the x-axis is showing the timestamp. The y-axis is showing the utilization in terms of the memory. So you can see all of these. The networking related, how much network traffic is coming into each and every namespace level, how much network is going out, right? Probably if I come back here, maybe if I go to the pod level, so here you can see that I want to select the namespace. Then you can select the pod as well here, which pod that you wanted to look for the utilization pattern. So now you can see the CPU utilization for each and every pod level in terms of the time-based graph. And you can see the memory utilization of this specific pod, how much is being utilized. Basically, this data will help us to understand how your application is behaving when there is a spike, right? Whether the given request and limit capacity is sufficient, or I need to do little changes there. You'll get to know all of these by looking into these graphs, guys. That's how this will be helpful for you. In general, the interviewer may ask you, hey, how are you going to monitor your applications? So the answer is Grafana, and hardly they may ask you, can you tell me something? What is that you can see in a Grafana? What kind of the metrics that you will be looking at the Grafana, right? So basically, this is the usage pattern at a worker node level. You see, I have two worker nodes, right? In each worker node, how much CPU is being utilized, and the CPU is being utilized for which pod exactly. You see, all these are the different pods that are currently running in this worker node, and you can see the utilization. That way you will know exactly, right, which pod is causing more utilization on that worker node, and you can look after that and see why it is consuming more, or at least see what is the request and limit of the each and every particular pod. That's how it helps us to do some analysis to, right, look after the things, guys. Just worth it to deploy this and go over with these different metrics once. So again, this is the node level metrics only. You see the disk space as well. This is one of the beautiful metric. Let's say if at all you are attaching the EBS volume, mounted it into the pod level, right, as part of the PVPVC concept. What is the actual volume utilization? You can get to know all of this here based on the data that it gets stored it into the volume. That's it. That's about Grafana, guys. So all these dashboards are populated automatically just because of the manifest files that I have taken here. So these manifest files has the specific rules set up, how the dashboard should come up, and we're just coming up all of this. I think there should be a manifest file maybe here, grafana-dashboard definitions.ml, right? So somewhere there is a manifest file which is talking about how to show all of these dashboards, which we don't need to worry at this time, because you see the manifest file, it has 35,000 number of lines, guys. Okay, so technically not possible to go over with this whole bunch of manifest file, but having the idea how the things will work out is good enough. Good. Now let me come back. Yeah, I think that's about the Grafana and the Prometheus stack project, right? So having some idea what is Grafana, what is Prometheus, how it is being deployed is good enough, guys. Now coming back. Now let me talk about Elastic Stack. Again, like the requirement is just go back to my microservices slide. So whenever you have multiple microservices are in place, right, again the Grafana and the Prometheus stack is solving some sort of problems, right, in terms of the monitoring aspect of each and every application. But the other thing, like let's say the application logs are showing some kind of the errors or the warning. Hope you all know, right, how to see the logs of an application. In general, what is the command, guys, to see the logs of application? Logs and the metrics both are different, right? Let's say how the application called Grafana is running here, right? So kubectl logs is the command to see the logs, correct? So this is how you will be looking at the logs for any troubleshooting purposes, right? If your application is not behaving correctly, right, some errors are reporting, right, someone is not able to access my application, right, what kind of the error that it is showing, right, all of these things can be seen in the logs command, and this is how you can see the logs, right? So the problem here is when you have multiple microservices like this, right, it's not possible to go to each and every microservice and look into the logs to see if the logs are showing any errors or other warning. Getting me? So if you have 100 microservices running like this, Maybe every day I wanted to know, is there any errors reported by all of my applications? Is there any warnings that are reported in the logs by these applications? It's always better to proactively go and look at the logs to see if any errors are reported, correct? Until someone is complaining. So now we need a centralized logging, in the sense rather me going to the each and every individual pod and running the kubectl logs command to see them, it's better to collect the logs of all these applications and put together all of these logs it into one single location, guys. That is where now the topic towards the centralized logging solution concept, which is the elastic stack. So to collect the logs of the applications that are running in the pods, here we are using the log collector. Like sometime back, I was using the Prometheus, right? The Prometheus was called as a metrics collector, which was collecting the metrics of your application in terms of the utilization pattern, right? Or the behavior. So to collect the logs, we need to use the log collector. FluentD is one of the famous log collector software, which is the open source. You just need to deploy the FluentD application. Again, the FluentD will be running as one of the pod. Okay. So this FluentD application is now responsible to collect the logs of the application that is running in. When I say logs, the logs will be generated on a specific location, correct? Remember, guys, if it is Apache web server, right, the logs will be available in the /etc http logs folder. There is a file called access.log, error.log. That log file will be keep varying based on the application, correct? If it is a Spring Boot application, the log file location may vary. If it is a React application, the log file location may vary, right? So even the log file location can be customizable as well. So if your application is generating the logs it into different location, maybe probably you need to tell to your FluentD application that, hey, which type of logs that it has to collect, right? Which location of the logs that it has to collect. You got me, guys? Let's say I have the Apache web server that is running in the pod. I don't want to collect the error logs. Sorry, I don't want to collect the access log. Maybe I wanted to collect only a error.log file, correct? So exactly which log data that it has to collect, that information we need to keep it into the configuration file called fluentd.conf file. Then you give this fluentd.conf file to the fluentd application. So whatever is defined in the fluentd.conf, whatever you define that, hey, what kind of the logs, right, which location of the logs, whatever is described in the fluentd.conf, accordingly the fluentd application will be going and collecting the logs from the running applications. Are we following now? That means what? All what we need to do is we need to deploy the fluentd application, which will be again running as a one of the pod. But the FluentD application is now taking the help of the fluentd.conf configuration file to understand the way how it has to collect the logs, which type of the logs that it has to collect, from where it has to collect the logs, from which namespaces that it has to collect the logs. All the data, right, will be getting it from the fluentd.conf configuration file. Let's say tomorrow if I ask you, hey, please collect the logs of the the dev namespace. So that is something that you need to update it in the fluentd.conf saying that, hey, collect the logs from dev. If I ask you that don't collect it from dev, collect it only from production namespace applications, you update it in the fluentd.conf accordingly. That's how we can tweak the fluentd as and when, right, the requirements, guys. Looks good. Now the behavior of the fluentd, right? The FluentD is the log collector, but the FluentD application is capable to collect the logs of a worker node where the FluentD is running. Let's say your Kubernetes cluster has multiple worker nodes. Let's say there is a second worker node here. The Fluentd pod that is running in the first worker node cannot collect the logs of the applications running in the second worker node. Getting me? So the Fluentd is capable to collect the logs of the pods, whatever the pods running on that same worker node only. Being said that, now you need to ensure that your Fluentd application is running in all the worker nodes. Are we good on this? If you have two worker nodes, you ensure that the Fluentd pod is running in both worker nodes. Then the Fluentd pod that is running in the each worker node is responsible to collect the logs of the applications running on that specific worker node. So if you have the second worker node, you should be having the Fluentd application running as a pod in the second worker node also. That is now responsible to collect the logs of the pods that are running in the second worker node, guys. If you have 50 worker nodes, you should be having how many replicas of the Fluentd, guys? If you have 50 worker nodes, you must be having 50 Fluentd pods running, one in each worker node. Then only it can collect the logs of that specific worker node applications. But how do you manage that? How do you tell that the Fluentd must be running in each and every worker node? It won't be possible just because of the replica count, right? Let's say in the replica count, if I tell 50, there is no guarantee that all the 50 replicas will be running in each and every worker node, because the replica set controller will not worry about the pods are running in one worker node or in multiple, right? You just need a count. So deploying this Fluentd application, as a kind deployment with replica count is not suitable in this case, because I have a hard rule that the Fluentd must be running in each and every worker node, and the worker node counts will be keep on changing. Let's say today I have a 10 worker nodes. Tomorrow maybe you are increasing the worker nodes to 20, correct? So this type of the behavior, this type of the log collector applications must be get deployed with the Kubernetes resource kind called daemon set. Daemon set is the Kubernetes resource. The daemon set, the deployment, both are like a same. Both are same. The only difference is the daemon set will ensure that your application is running in each and every worker node. If you have 10 worker nodes, it will deploy 10 pods, one in each. If you have 20 worker nodes, it deploys 20 pods, one in each. That's the behavior of the daemon set. Right? So that means the Fluentd application here I'm deploying with the kind called daemon set. So you don't need to tell about the replica count as well. The by default the daemon set ensures that how many worker nodes, let me deploy in one in each worker node. That's the behavior, guys. Looks good. Now once once the Fluentd application is able to collect the logs of the applications, those logs will be pushed to a database, obviously, right? The data that is collected, the logs that are collected should be stored somewhere, right? So all that logs now will be stored into a database, the database called Elasticsearch. Elasticsearch is the database which is storing the data, like MySQL. You already familiar with the MySQL, right? The MySQL is the database to store the data into a tabular format. Like that, the Elasticsearch is the one other type of database which can be stored your log data. My Elasticsearch is the database which is more popular to store the log data and for the searching related data. right? So here the Fluentd is pushing the data to the Elastic database. The Elasticsearch database will store the data. Whatever the data that gets stored it into the Elasticsearch, that data will now be published to a user in a nice UI format with the help of the tool called Kibana. So Kibana is a software which is capable to read the data from Elasticsearch and show the data right to the users in a nice browser. I mean to say a nice UI format in the browser. That's what it is. So now to achieve this overall centralized logging solution, right? Let's say now all the pods, whatever is running in the cluster, the logs that you can see it in the UI. You just go to the browser, access the Kibana dashboard. You look at the logs of every application at one single location. You don't need to run a kubectl logs command in each and every individual pod. So now just to make it working, right? So the Kibana is helping as a front end in order to show you the UI. The Elasticsearch is working as a backend to store the data. The Fluentd is working as a log collector responsible to collect the logs and pushing it into the Elasticsearch database store. So the combination of the Kibana, Elasticsearch, Fluentd is called as a Elastic Stack. So again, we don't need to be expertise in understanding how the Fluentd works, how the Fluentd configuration works, how the Elasticsearch database works, right? So understanding what is centralized logging and how to go to Kibana dashboard to look for the logs if at all you get any errors are reported just for troubleshooting purpose and what kind of the error it is. It makes your life easier for troubleshooting the issues rather going to the kubectl logs command for every individual application, guys. All right. If then, how to deploy this? So as usual, right, here you can see the Kubernetes Elasticsearch, Elastic Stack project. You can see the manifests, right? Right, we can see the manifest for Elasticsearch, Fluentd, Kibana. We just need to get these manifest files and deploy. So again, the manifest files that I downloaded from their official web portal are kept into my Bitbucket repository too. Let me go ahead and deploy them. So here you can see these things. So if you closely look at this one more time, right, probably this, right? I'm saying that the fluentd.conf is the configuration file where you need to define the behavior or what kind of the logs, from where the logs has to be collected. All the data will be there in the fluentd.conf configuration file, right? Remember guys, in general, if your application directly running on the EC2 instances, right? If your application directly running on the EC2 instances, you all know that the application related configuration file will be there and so on so location. You go to that location by using cd command, open the config file and you do the changes to change the behavior of the application, correct? I have shown that in Apache web server, SSH application. But the thing is, if your application is running on the EC2 directly, it's very easy. I'll go to the file, I'll modify the file and I'll save it. I'll restart the service. But if your application is running in the pod level, if your application is running in the pod, do you think you go inside the pod and you modify the .conf file? What is our base rule, right, guys? The base rule is you will never ever do any changes manually by logging into the pod shell, right? Whatever you are expecting, that should come from your image only, or at least from outside of the pod deployment, correct? You will not be doing any single change inside the pod by doing the shell. Are we good on that statement? So being said that, now I have two options to keep this fluentd.conf updated. Option one, you update the fluentd.conf file and you add it as part of the image itself. That is one option, correct? You update the file, you copy this file into the Docker file, you put it into the image itself, and you deploy it as part of the deployment, right? The fluentd.conf file will be available. It will be up and running. That's one option, right? That is not a recommended option because each time when I wanted to do a change to my fluentd.conf configuration file, you need to keep on updating your image, right? So these kind of the configuration files, I wanted to keep it outside of your image, guys. I don't want to merge them it into the image itself. So to provide this configuration file, right, to the applications not part of the image, we have the concept called config map. In Kubernetes, we have the concept called config map. API version is v1, kind is config map, it has a metadata, the config map name. So in the config map, you define here, you see, this is the configuration file, the configuration data, configuration file, the configuration data. This is exactly the configuration file that I wanted to give, the fluentd.conf configuration file. There's one more configuration file, the configuration data. What I'm doing here, basically I'm trying to keep all the configuration that I wanted to give to my application in a config map file. In this config map file, somewhere if you look at right, it has the details like which file that it has to consider for collecting the logs. You see the file here, guys? Hey, get the data from so and so log file, get the data in so and so time format, right? So that's how you prepare your fluentd.conf configuration file. Put all of your settings here. All these settings are now saved, right, in a Kubernetes with the resource kind called config map. So you do your settings here, and again, I'm not going to a line by line because you see here, which is almost 400 plus number of lines, right? So at high level, right, this file has the details like the log data has to be collected from which location and on like the interval rate, how frequently it has to collect the data, right? That kind of the settings are there, nothing much. So you define your settings here, how the Fluent should work, and then you create a config map. Let's say a kubectl apply -f a fluentd -config.ml. If you apply this file, then all the configuration data that you kept here, right, that will be created as a config map. I can show you that. kubectl get config map. You see, where is that, guys? Kube-system is the namespace. So somewhere you can see that a fluentd hyphen es hyphen config hyphen something, right? This is the config map that I created. In this config map, now the entire configuration data is available. Are we good on this statement? Now, when I'm deploying the application, you see there is a one more manifest file here, elasticstack.aml. So in this application, let me copy this config map name. Let me search for this. You see somewhere? Yeah. You see here, guys, the line number 53 in this files. I'm deploying the kind daemon set. I'm deploying the fluentd application as a daemon set so that it ensures that it automatically runs this fluentd application in each worker node with one copy in each server. Good. In this daemon set, when I'm deploying my fluentd application, in the template section, I'm defining that there is a config map that is already created with this name. This config map, right? This config map has to be get mounted into this particular location. That is what I'm defining, guys. Right? You see the name is config-value, and this is the name of the config map that I created some time back. This I'm representing it here again, saying that the mount path is so and so on. What does it mean? All the different configurations that you added in this file, the config map, now will become available in the etc fluentd config.d location. So the fluentd application will pick up the configuration files from this location and will be started and will be behaving accordingly. If it is direct EC2 instances, usually you go to the etc fluentd config.d location, you see ls-l, you see the files, you edit the file, save it, and restart the application, correct? Since here it is running as a pod, I don't want this config file to be part of the image itself, and I'm supplying this config map, right, externally. How I'm doing? You save the details in the config map, you mount the config map it into the required location. Now application will start from there. So here again you see that it has almost how many, guys? 300 plus number of lines are there, but it has the service for Kibana, which is a load balancer type at this case. That's fine. Of course, it can be cluster IP as well, but here it is showing load balancer kind. That's okay. It has a deployment for Kibana to deploy the Kibana application with one replica count. It has a stateful set as well. I'll talk about the kind stateful set in a while. So here the stateful set kind is used for the Elasticsearch deployment. Here you can see that the Elasticsearch is deployed as a stateful set with the replica count 2. And this is the image that it is using to deploy the Elasticsearch database. It is creating some kind of the cluster roles as well to give the permission. You see the cluster role, creating a service account, cluster role, the cluster role binding, just doing all of this. Yeah, this is for daemon set for the fluentd application. I'm just high level going through this whole file, guys. Okay, so let me deploy this for now. kubectl apply -f elasticstack.ml. I think this elastic stack is being deployed it into the kube-system namespace here. So kubectl get the service on kube-system namespace. So here you can see that the Kibana is deployed as a load balancer type service, and it is automatically created the required load balancer for you. If you want, you can deploy it as a cluster IP service, and you can create a ingress resource as well. Let me try to access the Kibana. Create a record. Let's say I wanted to access the Kibana, route the traffic to this load balancer endpoint. Kibana.shopper.com. Do I need to give the port number, guys? Yeah, because this is not an ingress, right? That's the reason it is expecting the port number to be supplied there. If it is through ingress, so by default it comes to the port number 80 that internally take care of. So this is the Kibana UI, and it's a very huge project, guys. Okay, I meant to say it's a huge concept. The Kibana itself will become the separate course altogether. Okay, so don't worry about understanding each and every tab that you see in the screen. Okay, so in the Kibana, if I simply go to the discovery here, and this is where I'm telling that uh, get the data from Elasticsearch and show the data it in here, right? The way how the MySQL will have the concept called table, the Elasticsearch database will have the concept called indexing, and this is the default index that gets created. I'm just telling that, hey, get the data from this index and show me that data, right, uh, in my uh, UI. That's it. Yeah. So this is what I would like to show you guys. This is how the logs will be collected from your applications running in the pod, and that logs will be shown here. So it's very easy for now to do the troubleshooting. It is exactly showing when the log is created, what is exactly the log message. You see the log message, the pattern as well here, at what time, how many logs are created, and you can see all of these logs here, right? And it exactly has the details like the log is created from which pod, from which container, right? From which namespace. Everything is there here, and what exactly the log message. So let's say I wanted to know, is there any errors that are reported by any of the microservices in my cluster? I can just search for here. Hey, I wanted to know any logs that are showing error. Now you see, it will filter the logs and it will give you the logs wherever it is finding that error. Then it's very easy to go to that specific log and see which pod that it is and why this error is reporting there, and start doing the connection issues or whatever it is. That's a easy process, guys. And you know exactly which time the errors are reported, how many errors are reported, all this stuff. That's the high level how the Elastic Stack is helping us to have the centralized logging works. Looks heavy, yes, but knowing more on Kibana is not so simple, guys. Okay, it will become a different job role altogether who is working on the Kibana dedicatedly. Because let's say now I'll ask you, can you prepare this filter in such a way that show me the errors only on the production namespace, not all the namespaces? Then how will you filter here? How will you filter to show the logs only on the production namespace, right? So it's not easy, right? For for applying the filter here, we need to have a Lucene a query syntax. You see here, it has its own programming language itself to apply this filter based on the requirement. So if I open that right, it has its own syntax as well here. So this syntax will tell you how to follow the Lucene language syntax to apply the filter and get the things and all. So it's really a heavy concept understanding the Kibana itself and customizing your filters and the graphing format. But yeah, need not to worry about understanding all of these, learning them as well, not needed at this time because it itself will go as a different role altogether for an observability engineer. Mostly you guys will take care of looking into the dashboard and see is there any errors reported by your applications. Writing this Lucene query syntaxes and plotting this right uh, uh, the dashboards, all of them will be done by the observability engineers. Could be a different team who is taking care of these things. And even we can set up some alarms as well. I mean to say alarms as well here. If at all the production namespace, if the errors are more than 10, please send a email automatically. All these things can be set up in the Kibana, which is not a scope for us to discuss, but I'm just telling. So that will be done as well by the different teams who are is responsible. So that's how the automated emails will be coming in if at all any pods are throwing any errors case. Are we good on this? So as part of the today's concept, right, I introduced a daemon set, I introduced a config map. Probably the time for you to show you the config map one more time, how that is working. I'm just trying to shell into the Kibana, not Kibana, Fluent Depod. So probably I'll go to the kube-system namespace. And here I can see a Fluent application. You see here, the Fluent is running as two replicas. Why? I have two worker nodes, one in each worker node. I have two Fluent running here, right? Let me shell into one of the Fluent pod. Now in the Fluent pod, I really wanted to go to this location, etc fluentd config.d ls-l. You see guys, system.conf file, system.input.conf file, monitoring.conf file. These are the configuration files that you added as part of the config map. If you go back to the config map definition here, you see system.tf. This file should have this data. That's how you prepared the config map, right? This config map is mounted it into this particular directory and all of these files are available here. Now the Fluentd application will take the config from these files and will be loading and will be working accordingly. So tomorrow, if I ask you, hey, can you do a small change to this config map, sorry, to this configuration file, you don't need to do the changes here, right? All what you need to do is do the change in the config map manifest file, modify the settings and apply this config map. That gets reflected it into this particular pod as well. I just wanted to confirm how the config maps are used here for configuration files. Many things. sorry, let me exit. So here you can see that I'm just looking into the secrets, right? If I look into the secrets here, there are multiple secrets here. Probably, I'm just trying to see. The screen is hang. Well, so here you see, guys, there is something called secrets. And here we see, right, for example, I'll show you the Prometheus, okay? So let me show you the data. Okay, the code is not working. Yeah, this is at least better. So currently I'm looking into the Prometheus secret. So basically, secret is the concept in the Kubernetes which is storing your sensitive data like a, username and passwords. Config map is using the configuration file store. The secrets are used for storing the username and password. Both are kind of same only purpose. So here I'm using the Prometheus hyphen K8s secret. And here if I look into the data, right, it has some secret in the encrypted format. You see the data here. So whatever the junk data that you see, right, this junk data is actually a kind of the password that it has to use for connecting to the Prometheus database. And you see here the kind is secret here. So the kind is secret, the metadata, the secret name, right, and it has the the secret in an encrypted format here. So so if I come back here, right, maybe I'll go back to the Prometheus Grafana. See, the Prometheus is the database, right? To get the data access which is stored in the Prometheus, the Grafana has to connect with the Prometheus, correct? If the Grafana has to connect with the Prometheus, Prometheus is actually secured by its own credentials. So we need to supply the credentials to get the data from the Prometheus that it can show it in the front end UI, correct? So that kind of the credentials to access the database, the credentials will be stored it into the Kubernetes secret resource. The Grafana will use that secret, get the credential and connecting to the Prometheus. That's how it works, guys. Remember in older lectures, I was showing like, uh, the in SRC main resources application dot properties file, I was keeping the database username and password in the plain text format, correct? So that the application will use that username and password to connect to the database, right? That is not a best practice. We should not keep the username and password, right, in an application or properties file in a plain text format, correct? So rather keeping it in the plain text format over there, we need to keep that username and password to keep it in the secret. So I'll try to create a simple secret now just to show you what it is. A question at this moment for you guys. When I'm keeping the username and password and the RDB are like the database endpoints in the application properties, how the details will be get effective? I'm going to say your developer has to support for it, right? If the developer has written a code to read the data from src main applications, src main resources application or properties file, then only whatever the data that you kept in will be get read and will be used by your code, correct? Let's say your developer is not written the code to get the data or to read the data from application or properties file. Then though you keep your username and passwords in the application or properties file, will that take into the effective? No, right? Just look at that perspective. That means it's all up to the developer how the developer code is written to read the data. If the developer's code is written to read the data from application or properties, you put that data it into application or properties file. If the developer says that no, my data I can read it from a secret, then you need to keep the data it into the Kubernetes secret. Then developer handle how he wanted to read the data from the secret. Getting me? So now from your perspective, you just need to understand how to create a secret. Let developer take care of how their code is written to read the data from the secret, right? So can you help me a simple Kubernetes secret manifest? So all what you need to do is understand this. This is how the Kubernetes manifest file there for adding the secret. API version is v1, kind is secret, metadata is the secret name, the type, this is the generic secret type, OPAQ in the sense. So you're just keeping your username and password. Okay. So the username is here and the password here. That's it. Now when you apply this file, then it creates the secret resource. It will keep the username and password in it. Now the developers who need this username and password, the developer know how to read it from this secret, right? How to use these credentials in their code in order to connect to a specific endpoints. You will never ever keep the passwords in the application.properties file the way how I kept it in the plain text format the other day, right? Will not do that. So any passwords will go it into the secret. You need to keep the secrets here. And even here, you are not keeping the username and password directly. You are keeping it in the base64 encoded format. Let's say my username is admin, right? Then you will not keep it as admin here. All what you need to do is encrypt that it into base64 format. So basically this website will help us to do the encryption. For example, my username is admin, right? I wanted to encrypt this to a base64 format. Now you got this, right? This is the thing that I need to keep it in here. That's it. Now let's say my password is admin123. Then you encrypt admin123, right? Encode it. And this is what is, I got it. Let me put it here. So now you apply this. So kubectl apply -f secret.yaml. Now this username and password will be saved in the secret resource, right? The developers will use this information for using this data, and they know that this is in a base64 encoded format. It will be decoded, it will be used as a admin only. That's how a little more security is there in terms of the way how we are handling the credentials part. So it's up to you. You would like to keep it as a encoded format, or you wanted to give it as a plain text format. Giving it in an encoded format is just a more best practice way. Right now the secret is created. Now this secret is being used wherever you wanted to use these credentials for a connectivity per se. So that way, now you don't need to keep this username and password in the application or properties file. You can get that from secret file, right? That's how it works. The same concept might have been followed in our deployments as well. Let's say when I deployed the Grafana stack and all, right? So I'm sure it might have been created the secrets as well. You see here somewhere it has bunch of files. Somewhere I can see the secret here and the data. Here we can see the data in a plain text format only, but it can be encoded as well, right? Yeah, that's the overall concept for today, guys, right? So as part of that, you just need to have some idea what is Grafana and Prometheus stack, what is Kibana stack, and the daemon set and the secret and no, uh, daemon set config map.